Connor?
So first you can sketch the angle.
Yeah. Making a diagram, visual, even if you don't want to draw a circle, but having something to look at to see where the angle is located is a really good way to try and find anything with trig. So by now you should see that like diagrams and trig kind of go hand in hand. So visual learners, trig's great. Draw a picture. You might be able to work through the problem. So Connor, if it's negative, we're going?
Clockwise.
Yeah, so we're going clockwise. So right here is 360 degrees that we've spun around. And it's negative 480. So Connor, how much extra do we need to go?
120.
Yeah. So if I've already spun around 360, we still need to go another 120 degrees in the negative direction to get our angle. So if you were asked to graph it in standard position, that would be our angle graphed in standard position. Again, make sure that the rotation is obvious. So it should be very easy to see how it's rotating, the direction, how much it's spinning around. And then the reference angle has to be positive. By definition, it's a positive angle. And it should be less than 90. If it's greater than 90, it's not a reference angle. So that reference angle takes us from the x-axis to the terminal side. And what would that reference angle be, Connor?
60 degrees.
Yeah, so right here is 180. I went an extra 120 to go past my 360, and if I subtract those two, or if I add 180 to it, you get a 60-degree reference angle. So the reference angle is 60 degrees.
I'm so sorry, I spaced out a little bit. Why did we add 360 degrees?
Because you've already spun around once. So I've rotated one time, so that gives me like the leftover portion that I can think about to use to find the reference angle. Other questions? The second one, we have 15 pi over 4. Again, as Connor said, graph it. Because this is radians, we can divide our circle into 4 pieces on the top, 4 pieces on the bottom. And then you just count pieces of pi. So Odette, 15 pi over 4 would be located in the 4th quadrant. So here is 4, 8, 12, 13, 14, 15. Visually, once you have your graph drawn and it's already divided up, the reference angle is this little piece here. And Odette, that would be pi over 4. When it's a radian, your reference angle, in most cases, is just going to be whatever the denominator is, pi divided by the denominator. In most of the cases. Questions on those two? So I'm not going to go over the answers to the chart because you can look on the front of the packet, you can look in your unit circle, you can look on your trig chart, but hopefully you were able to fill this out, maybe not with 100% confidence, but pretty close to that by now. Rebecca, no, not 100% confident?
What? Yeah, I'm good.
Okay. Like, do you feel pretty confident about filling this chart out? Working through, like, write your ordered pairs next to it, 31, 22, 13. Use those ordered pairs to use the sine y, cosine x, tangent y over x. So the tangent you might not have memorized, but you don't need memorized because you're just taking y divided by x. Kevin, you good to sit down now? Yeah.
Oh, are we doing a lesson today?
Well, I'm going to talk a little bit. Oh, good, thanks. I mean, unless you want to teach. That would be, wouldn't it? Someday we'll let Kevin. All right, so if you look at the worksheet and looking at number 5. So number 5, use the calculator to approximate 4 values of theta between negative 360 and positive 360. If that number is in degrees, then your calculator mode should be in degrees. Don't have it in radians because it's not asking for an answer in radians. So whatever is in parentheses is how your answer should look. So if there's degrees in parentheses, then your answer should be in, or I'm sorry, if there's degrees inside the parentheses, your answer should match that degree. Don't convert it either because then, yeah, they are going to be slightly off because you're not using the exact value. Kevin?
I was confused because the numbers didn't have like degree sign after it. like cosine of the angle was negative 0.5.
Because this isn't a degree value.
Is that a?
It's not a radian value.
Oh, okay.
Unless I know if my circle is measured in inches or feet or centimeters, like this is a length
Okay.
of the y-axis or the x value on the circle.
Okay.
So it's not a degree value because it's not an angle. I'm solving for the angle. So the angle is in degrees or radians, but that answer, unless they told me I had a circle that was measured in inches, then I really don't have a measurement or a unit to go along with that. Does that make sense? So if we have cosine, Rebecca, cosine is x or y? X, and right now we know it's a negative x. So Rebecca, on the unit circle, where is cosine negative? The second, because x is negative on the second. And I'm just going to draw another diagram so that I don't have 15 little arrows going in all the directions. And also the third. And if you need to draw separate diagrams to make it easier for you to understand and visually look at, that's fine. So we need to get an angle in the second quadrant. We need to get an angle in the third quadrant. So using your calculator, anytime you're finding an angle, Mackenzie, how would I use the calculator to find an angle? You do the inverse. If you know the angle, then you just plug it in because you're given that angle. But we don't know it. We're trying to find it. That's why we have to use the inverse. And Mackenzie, what does it give you when you plug that into the calculator? And your calculator mode is in degrees. It is 126.09. And Mackenzie, one more question. 126.09 degrees is in what quadrant? Second quadrant. So that matches the angle that we're given, or that we're trying to find. Because my angle I need for cosine is in the second quadrant. The answer from the calculator matches that angle. But we need to find that angle that goes into the third quadrant that passes 180 degrees. And you cannot just take 180 and add 126.09. Does anybody know why you can't just add 126.09? Good? Exactly. It's not a reference angle because it's bigger than 90 degrees. Quinn, how would you find its reference angle? So we need to get the reference angle, which is that little angle right there on the other side. Jacob, how do you find that?
Subtract 126.09 from 180.
Yeah, so you're going to take the angle that you still had in the calculator, so you're still using that, but you're going to subtract it from 180 so that you know the reference angle. And Jacob, that is?
53.91.
53.91. So right here, that's the reference angle. And I need to find that so that I get the correct angle in the third quadrant. Because if you just add 126 to 180, that takes you to the fourth quadrant. Cosine is not positive in the fourth quadrant, it's negative. So once you have the reference angle, now I can get my angle in the third quadrant because I need to use that reference angle to pass 180 by 53.91 degrees. So if I add those two together, Jacob, we get the second angle of 233.91. So quadrant 2, 126.09, calculator gave us that answer. To get quadrant 3, we had to find the reference angle first, and then use the reference angle and pass 180 degrees by that to get 233.91. Questions on that?
I didn't use a reference angle. I just subtracted it from 360.
So that would have been another way that you could have done, because yes, that happens to be this angle here as well, going the negative direction. Other questions? So we have two answers, and we have the two answers that are positive. Anytime you're asked to get the negative angles from negative 2 pi to positive 2 pi, negative 360 to positive 360, how can you use the two answers you just found to find the other two angles that would be negative? Kevin? Yeah, subtract 360 because they're coterminal. So in my diagram over here, we want this angle that goes the other way. still starts the same place, still ends the same place, but we want the negative angle. So together they should make a circle. So if I have the positive, if I need a negative angle, you take the original and you subtract 360 or 2 pi. Every single time I need a negative angle of the positive one, I would subtract 2 pi or 360 depending on what we're working with. This happens to be the exact opposite of my quadrant 3 angle, and it just works out that way for cosine. It doesn't work that way for all of them. So 126.09 and negative 233.91 are both in the second quadrant. It's just one goes positive, the other one goes negative. And then if I take my third quadrant angle and subtract 360, we also end up with that negative 126.09. This angle is in the third quadrant. This angle is in the third quadrant. It's the angle that goes the other way. Questions? I was the only one on that page that you could not use the given angle as a reference angle because it is too big. All the other ones, the angle you got from your calculator, you can then use as its reference angle, except for this one. So in your review packet, or in your notes packet, you can turn to page 36. And if you started this, awesome. If you haven't gotten this far, that's fine. Some of you may have gotten to 16, others you didn't. You didn't have time, that's fine. Both review worksheets are due on Monday. So I wanted to go over 16 because it's pretty much the same type of problem that we just went over. Find two values, so we only need two. And if I didn't say two values, how would you know you need two? Because I'm not going to say find two values. Maggie, how do you know you need two? Right, it starts at 0, it's not negative. So if it starts at 0 and goes to 360, then I need two positive. And it's always 2 or 4. It's never 1 or 3. Because odd numbers get left out. So you either have 2 angles or you have 4 angles. But this is saying just find positive angles from 0 to 360. That satisfies the fact that the cosecant is 2.5593. So before you quickly refer to that calculator, what do you have to think of first? So like, what would we think of if you have cosecant? Taylor? Yeah, so we can't use cosecant, but we can use the reciprocal, so you have the sine. So 1 over 2.5593. The other thing before you refer to that calculator, get a little diagram, like mentally, physically draw it, but like know where the angle is supposed to be. So if we have sine, and it's equal to a positive number, sine is y. Katie, where is sine positive? Quadrant 1. And where else is y positive? 2, yeah. So if sine is y and y is positive, my answers need to be on the top of the x-axis, because that's where y would be positive. So I just separated instead of drawing them together. So now you can use your calculator. Plug this in. You're taking the inverse sine 1 divided by 2.5593. And Maya, what answer did you get from the calculator? Is your calculator any answer to Grace? Maybe that should be the first step. Look to see how we want our angle to be. 23. Yeah, that sounds good. 23 degrees. So 23 degrees, Maya is in what quadrant? First one. So that must be one of my answers. It's in the first quadrant, matches with my diagram, so there's 23 degrees. Can 23 degrees be used as a reference angle? Yes. So if I look at my second diagram, right here is also 23 degrees. So it's my answer, but I can also use that answer as the reference angle to get the other solution, because we want want that solution to go into the second quadrant. So, Abby, how would you get the angle in the second quadrant? Yeah. And Abby, that second angle is 157. Questions? Now, if the question did say, find 4 values going from negative 360 to positive 360, how could you easily find those other 2 values? Maggie? So if I was asked to find 4, 2 positive I have, the 2 negative, we just have to take these answers and subtract 360. Does anybody know what 23 minus 360 is? Negative 337. And then negative, or 150 minus 360 is 203. Negative 203. Questions? Circle that question, star it, box it, remind yourself, go back and look at it. But finding 2, the positive, like that's getting the second one, that's where like the thought process. But then getting the negative ones, if you were asked to get the negative, you just add 360 or subtract 360. Anyone have questions that you were looking at on the review worksheet that you want to ask?
Just real quick for
Yeah.
number 15. So would the tan just be negative 1 as well?
Yes. Yep. So tangent is, God bless you, negative 1 as well. For number 2, I think your diagram looks way better than mine. I don't even know what this ordered pair is. Is it 8, negative 7?
Yeah.
Yes.
Yeah.
So then when you square both of those, you are going to get a high number.
It's the square root of
Because you're taking the square root of 113.
113.
Is that what you have?
Yeah.
Other questions? Okay, so the rest of the period, 16 minutes, is yours to work through. If you'd like to use a partner, that's fine. The answers to the second worksheet are not included in the packet, but they are posted on Google Classroom, so please make sure you're checking these answers. Monday, come to class with any questions that you didn't get answered today. And then also on Monday, we are going to take that wonderful unit circle and try and pull it apart and make a nice picture with it by plotting all of the points of the unit circle. So we're going to take the points of the unit circle, each one of those 16 ordered pairs, we're going to graph them and see what happens.
So like a circle.
It won't make a circle. It won't.
Like a triangle.
No, not even triangle. So grab a partner, ask questions. Please use this time. Ask.
16 of them.
16.
I don't think it's gonna make an octagon. It could make an octagon.
Thank you. You're welcome.